Let me check out the moon. Whoa! I wonder just how many moons there are.
I know how many there are in our solar system.
How many?
178 known moons.
178? Wow! Then there must be billions of moons across the universe.
The universe is everything that exists in space. All the planets, stars, solar systems, galaxies, moons, everything.
I can't even imagine all of that.
Luckily, scientists have sort of broken things down so we can try to imagine how ginormous space really is. Biggest to smallest, it goes universe, galaxy, solar system.
Okay, so a galaxy is smaller than a universe.
Yep. Ever heard of the Milky Way?
Yeah.
Well, the Milky Way is our galaxy. A galaxy is a large group of stars and planets. There are countless galaxies that form the universe. The Milky Way's just one.
These stars we're looking at tonight are part of the Milky Way, right?
Yeah, and there are more stars we can't even see. Billions and billions, all part of our galaxy.
They really are beautiful.
Beautiful balls of burning gases.
That pretty little twinkle of light we see is a bunch of flaming gas?
That's right. Every star is just a big ball of light-giving gas. Even the sun.
The sun is a star?
A sun is any star at the center of a system of planets. Our sun is at the center of our solar system.
Well, solar does mean sun, right?
Our solar system is the sun and the planets that orbit around it. Our solar system has 8 planets, several dwarf planets like Pluto, 178 known moons, asteroids, and comets, too.
Sounds like one jam-packed planetary party to me.
There's a lot out there, but it's not exactly packed together tightly. Just the distance between the Earth and the Sun is almost 92 million miles.
92 million?
Yeah! Actually, the universe is so big that scientists measure its distance in light years, or the distance light travels in a year. 1 light year equals 5,878,786,100,000 miles.
Phew, my head's spinning just thinking about something that big.
Well, let's bring it back down to Earth and talk about something you're a little more familiar with. Planets.
What exactly makes a planet anyway?
Well, a planet is basically a large body in space that does not give off light.
So, no flaming balls of gas?
No. There are 3 things that make a planet. 1, it must orbit a sun. 2, it must have enough mass for its own gravity to shape it into a sphere, just like the Earth. And 3, it must be massive enough to clear objects from its orbit.
This universe stuff is pretty unbelievable, Zoe.
And here you thought you were just gonna do a little stargazing.
Well, now that I know a little more about what I'm looking at, the view through this telescope's much clearer. Our sun and the planets that orbit it form a solar system. A galaxy is even bigger. A galaxy is an enormous group of stars and planets. I mean, billions. Our galaxy is called the Milky Way, and it's just one of countless galaxies that form the universe. The universe is so humongous that distances are measured in light years. The universe seems so simple, but...
It's simply enormous.
Zoe!
Alright, this is Unit 3. We're looking at galaxies, nebulae, and stars. Our learning target, we are describing components of the universe, including stars, nebulae, and galaxies. And we'll use models such as the Hertzsprung-Russell diagram for classification. We'll also recognize that the Sun is a medium-sized star near the edge of a disc-shaped galaxy of stars, and that the Sun is many thousands of times closer to the Earth than any other star. We live in a galaxy called the Milky Way. A galaxy is a system of stars, planets, gas, dust, and dark matter.
What is a galaxy? Until the 1920s, we only knew of our own galaxy, the Milky Way. Even with telescopes, we could barely see little fuzzy spiral shapes in the sky, and we wondered what exactly they were. Dusty nebulas? Or other galaxies entirely? There was a great debate about the issue. Ultimately, Henrietta Swan Leavitt's work on distances to stars enabled Edwin Hubble to prove that the largest fuzzy spiral shape in the sky was actually a galaxy entirely separate from our own, the Andromeda Galaxy. So cool! It was the beginning of our discovering and grasping the vastness of space. Since Andromeda, we've learned there are billions more galaxies outside of the Milky Way. Galaxies are concentrations of stars, gas, dust, and dark matter, all held together by gravity. Many galaxies are spiral galaxies, like the Milky Way, but there are also elliptical and irregular galaxies. As far as we know, all large galaxies have a supermassive black hole at their centers. We also know that galaxies interact with each other, creating beautiful new forms over millions of years. This is true for Andromeda and the Milky Way, too. Our galaxy is on a collision course with our nearest neighbor. While that may seem violent to you and me, galaxies are so huge that most stars will pass right by each other. Phew! Eventually, the Milky Way and Andromeda will merge into one giant new elliptical galaxy. It's not for another several billion years, but it's sure to be a spectacular show for the stargazers of the distant future.
We live in the Milky Way galaxy. We live on the outer edge in an area called Orion's Arm. So in this picture, or this image, you can kind of see where we would be in the galaxy. Within galaxies are dust-forming regions called nebula. A nebula is a cloud of dust, hydrogen, and helium gases. The word nebulae is plural for nebula. It is in these clouds of gas and dust that stars sometimes form. Sometimes you will see these referred to as stellar nurseries. A star is a large ball of gases that generates its own energy through nuclear fusion. Fusion is a process in which hydrogen and helium fuse to form heavier elements. This process generates large quantities of energy. That energy is emitted from the star in the form of heat and light. Stars will undergo many changes through their evolution. Depending on the mass of the star, its lifetime may be a few million years to trillions of years. Lower mass stars can generate energy for billions of years. Stars that are very massive generate energy for only a few million years. Our sun is only one of many stars in the universe. It is considered to be a medium-sized star near the edge of our disk-shaped galaxy. So knowing that stars evolve, what will happen to our sun? At the end of the sun's life, it will gradually brighten as it has been doing for the last billion years. Around 5 billion AD, the hydrogen in the sun's core will run out. The sun will expand into a red giant about 3 times larger than it is now. The increased brightness will boil the oceans and raise our temperatures to over 1,000 Kelvin. That is about 1,340 Fahrenheit. Eventually, the sun will shrink, but then expand again, charring the surface of the Earth with solar prominences. If Earth is not destroyed, it will become a cold, dark chunk of rock circling a white dwarf. Have a nice day.